So I've titled our next paper, Does Taking a Break from the Gym Really Hinder Long-Term Gains? A comparison of continuous and periodic resistance training programs on muscle size and strength. This paper was published by Hallinan and colleagues in 2024 in the Scandinavian Journal of Medicine and Science in Sports, so a nice recent publication. So let's take a look at the overview. Skeletal muscle has a remarkable ability to adapt to environmental demands. For example, in response to chronic resistance training, skeletal muscle increases in both size and strength. However, this innate plasticity of skeletal muscle is also shown after periods of inactivity. For example, when resistance training is discontinued, we see muscle size and strength begin to decline. Short-term detraining periods of, say, less than 4 weeks typically result in smaller magnitudes of muscle atrophy. However, longer periods in excess of 4 to 6 weeks result in much greater losses. Luckily, several studies have demonstrated that resistance training adaptations in muscle size and strength, once achieved, can be obtained at a much faster rate with subsequent retraining if the initial adaptations were lost during the detraining period. However, it remains rather uncertain whether this retraining effect on muscular adaptations is so significant that resistance training practitioners should not be concerned about the intermediate detraining periods. In other words, given the nature of how muscle size and strength gains can be regained at a heightened rate than initially gained, should one just not worry if certain life events preclude them from being able to train for weeks on end, and they then experience some loss of adaptations? Much of the research on this topic has included periods of detraining lasting around 3 to 8 weeks, and these studies have shown an ability to regain muscle size and strength adaptations to a similar magnitude as gained during initial training periods, for example, 6 to 8 weeks. The study that we're going to be reviewing today wanted to investigate whether similar findings could be observed with an even longer detraining period implemented. This study aimed to compare the effects of a 20-week continuous training period to a 2 10-week resistance training periods that are separated by a 10-week detraining period. So essentially 10 weeks on, 10 weeks off, 10 weeks on. So let's take a look at what the researchers did. The authors recruited 42 healthy men and women between the ages of 18 to 40 to participate in the present study. These individuals had no prior history of engaging in a regimented training program, and they had to have had completed less than 10 sessions over the past year. Participants were randomized into one of two groups. The first group was a continuous resistance training group, and that's abbreviated as CRT in our paper. And the second group was a periodic resistance training group, which was abbreviated PRT. The participants in the continuous resistance training group performed 20 weeks of training with no designated break periods, while the participants in the periodic resistance training group performed 10 weeks of training, followed by 10 weeks of detraining, followed by 10 weeks of retraining. For the periodic resistance training group, the detraining consisted of resuming their habitual lifestyle, but avoided any form of resistance or endurance type training or any other unaccustomed exercise during that 10-week period. The training sessions were identical for both groups and consisted of 2 whole body sessions per week with at least 48 hours of rest between each session. Table 2.1 in the magazine details the specific exercises along with the loading and repetition schemes for the training sessions. But just as a quick snapshot, the exercises included the leg press, the leg extension, the Smith machine bench press, and the barbell bicep curl, and finally the chest-supported seated row. Muscle cross-sectional area, or the CSA measurement, was assessed using B-mode ultrasound for the vastus lateralis and the biceps brachii pre- and post-intervention. The images were taken at least 48 hours after any exercise sessions. Dynamic muscle strength from the lower and upper body was assessed on the leg press and the barbell biceps curl using a 1-rep max test. Both muscle size and strength assessments were taken every 5 weeks throughout the intervention period. So, what did the researchers find? Regarding changes in muscle strength, both groups observed significant increases in leg press and barbell bicep curl 1-rep max after the completion of the entire training intervention. When comparing the changes from the continuous resistance training group after 20 weeks of training and the periodic resistance training group after the completion of their entire intervention, which was 10 weeks of training, 10 weeks of detraining, and then another 10 weeks of retraining, there were no significant differences reported. For changes in muscle CSA, both groups observed significant increases in the vastus lateralis and the biceps brachii using CSA after the completion of the entire intervention. And again, when comparing the changes from the continuous group after 20 weeks of training and the periodic group after their completion of the entire intervention, again, 10 on, 10 off, 10 on, there were no significant differences reported. The exact changes in muscle size and muscle strength are provided in Table 2.2 in the magazine. So let's talk about the effects of detraining and retraining. For the periodic group, the 10-week detraining period led to noticeable decreases. The leg press strength dropped by 5.4%, the bicep curl strength fell by 3.6%, and the size of the vastus lateralis decreased by 9.9%, and the biceps brachii by 7.3%. However, here's the interesting part. Just 5 weeks of retraining brought them back to the same level as the initial 10-week training period. And by the end of the 10 weeks of retraining, both muscle strength and size had not only recovered, but had surpassed the gains made during the first 10 weeks of training. Table 2.3 in the magazine outlines the changes in muscle size and strength for the periodic group throughout each 10-week period. So we can see week 0, week 10, week 20, and then week 30. And just as an example, the vastus lateralis CSA changes were as follows. At baseline, the muscle CSA measurement was 26.2 centimeters squared. At week 10, so 10 weeks of training, we see an increase to 30.3 centimeters squared. At week 20, which is after the 10 weeks of detraining, we see 27.2 centimeters squared. But then by week 30, we're back up to 31.3 centimeters squared. So what does this data mean for you and I? Well, in this study, the authors found that 10 weeks of detraining did not negatively affect resistance training adaptations in muscle size or maximal strength when comparing periodic resistance training to an equivalent amount of continuous resistance training in young, untrained males and females. The researchers noted that any muscle size and strength lost during the detraining were quickly regained, particularly with the first few weeks of retraining. These findings support previous research showing that both periodic and continuous resistance training are equally effective in improving muscle size and strength. And this phenomenon is likely linked to the muscle memory theory. This concept suggests that muscles retain the ability to adapt to familiar stimuli, potentially due to factors like preserved myonuclei, epigenetic changes, and neural adaptations. Interestingly, detraining periods may even help the central nervous system refine motor tasks and muscle hypertrophy pathways, enhancing early gains during retraining. In this study, retraining produced greater initial improvements than the first 10 weeks of training, though it's unclear if muscle memory was indeed the driving factor. So, further research is needed to uncover the cellular and molecular mechanisms behind this phenomenon. One important consideration when interpreting this study is that gains achieved over 10 weeks were fully regained in just 5 weeks of retraining in these untrained individuals. However, it's less clear how this applies to highly trained individuals. So, for example, someone like myself with more hypertrophied muscle might stand to lose more muscle during a 10-week detraining period than someone of a similar size who has only been training for 10 weeks. So that data might look quite a bit different for advanced athletes. And unfortunately, that being said, getting highly trained individuals to take 10 weeks off from training for a study is no small feat. In fact, Sam and I recently surveyed a group of university students, and the average highly trained person said that they would need anywhere from $500 to $5,000 in compensation to participate in a 10-week detraining study. So, if you've ever wondered why there aren't more studies on this population, it's probably because this is the toughest group to convince to hit pause on our training for the sake of research. So, in summary, the results of this study show that 10 weeks of detraining did not impair 20 weeks of resistance training adaptations compared to continuous resistance training in young, untrained females and males. Basically, this means it is less likely that taking a break from resistance training will cost you in the long run, so long as you re-engage in resistance training at some point within a reasonable time frame. And this study also shows up to 10 weeks does not seem to be too detrimental. So, what are our practical takeaways? Well, periodic resistance training, including a 10-week detraining period, led to similar improvements in muscle size and strength when compared to a continuous training program of an equal amount of time. Skeletal muscle demonstrates the ability to rapidly increase muscle size and strength during the initial weeks of a retraining period are likely because of a combination of our motor learning and epigenetic factors. And lastly, taking a break from resistance training may not be as big of an issue as we once thought, so long as we re-engage at some point within a reasonable time frame. So for those of you who might have been concerned about taking a few days out of the gym over the upcoming holidays, we have considerably less to worry about.